Hello everyone. Here are your notes for today. First of all, everybody needs to get a new note packet. These are green. So look for a green note packet that the substitute will give to you. And then at the bottom of this, if you want to write down your test is on May 20th. That's your next piece of information. Go ahead and skip past this page and go to page 3. And that's where we will start out today. So for those of you who were here last time, we talked a little bit about where the sine curve and the cosine curve come from. Then I had everybody make a large table of values, and we have a smaller one here, but we said what's happening around the unit circle at 0. So if this is the sine of x, at 0 the sine is 0. At pi fourths the sine is root 2 over 2. And then we said at pi halves we have the sine is equal to 1, and so forth. And what we end up getting is if we plot those points on just a regular coordinate plane, here's 0, 0. If we say this is 2 pi, here's pi, so this would be pi halves and 3 pi halves. Then this next coordinate here, pi fourths, root 2 over 2, ends up being about right here if this is 1. And at pi halves we get all the way up to 1, and then at pi we're back to 0. So anyway, we plotted a whole bunch of these points, and what we end up with is this curve right here, and this is called the sine curve. What is the domain of the sine curve? Well, it's infinite. What's the range of the sine curve? Well, it only goes as low as -1 and as high as +1. So we write that as bracket -1 to 1. The amplitude is the height of the curve. So how tall does it go above the axis? It goes 1 unit. So the amplitude of this is 1. The period is defined as how long does it take to go one cycle. If you were thinking of the circle, how long does it take to go one time around the circle? It takes 2 pi. So if we put this on a curve, it takes 2 pi until we get back to where we started. So think about this as a hill, valley, stop. If we continued this graph, it would continue with another hill, valley, stop, hill, valley, stop, etc. So how long does it take for just one section? That's 2 pi. Don't worry about the frequency. Okay? Now the cosine curve, we could do the same process again with looking at a table and graphing it, but it's very similar. The cosine curve, the only difference is instead of starting at 0, 0, it starts up at 1 on the y-axis. So I'm still going to draw my same period, 2 pi, pi, and then pi halves and pi fourths. But this time, instead of starting at 0, 0, I'm going to come down to pi halves, and then I have a valley, back up to pi fourths is 0, and then the start of another mountain. Okay? And then, of course, this would continue repeating over and over again because it's also infinite. But one period is still from 0 to 2 pi. So again, domain is infinite. The range is -1 to 1. The amplitude is 1, and the period is 2 pi. Okay? And that's what we talked about on Fridays. We just sort of discovered what these curves look like. If you go to Desmos, here's a sine function, and if I were to zoom out, you could see that this just continues going forever and ever and ever with the same curve. Okay? So then the next thing we did on Fridays, we talked a little bit about amplitude. This one right here, you can see that the blue has gone up higher. It has an amplitude of 2, whereas the red just went up to a height of 1. So if we change the number in front of the equation, we will get a different amplitude. And that's the first of what we're going to start talking about today. So go to the next page in your notes. If I'm going too fast, just pause and catch up, excuse me, and then keep going. So, at the root of this, we have the sine curve and the cosine curve. Other than that, everything else about these two formulas at the top of the next page is the same. We have an A and an A, and then a B and a C and a D. B, C, D. Okay, so here's the different parts. Amplitude is defined as the A in the function. The period is defined with B, but B itself is not the period. The period is, by definition, 2 pi, which was our original period, divided by B. So whatever number is in front of your x, you divide 2 pi by it, and you will get the period. Okay? The phase shift is represented by C. It will always have a sign change. So if it is a positive number, that means you move to the left, and if it's a negative number, you move to the right. The phase shift is the most difficult part of graphing these, and we will kind of keep working on that. I expect you to try it today, but I don't know if you'll master the phase shift today. And then a vertical translation isn't too bad. That comes from D, and that's just your up or down. It does not have a sign change. It shifts your entire axis. So if your sign is normally centered on the x-axis, a vertical shift might move that up 2 or something like that, and then your sine curve, the whole curve moves up. That's what a vertical shift does. Okay? All right, so here's your steps. When graphing, find the amplitude, find the period, find any vertical shifts, and find any phase shifts. Those are the 4 parts mentioned in this box. After that, we're going to sketch one cycle, label the 5 key points, and state the domain and range. We don't have to do this labeling part on every problem, but you'll get the hang of it after a couple. One thing I think is important to know is that basically you're drawing the same picture over and over again. You're just rescaling it. So for example, a typical sine function might have a period of 2 pi, and you'll write it like that. But then, let's say your curve looks like this. If your period changes, you're not going to necessarily draw it drastically different on your paper. You might just change it to, okay, now my period is 8 pi, so this is 4 pi, and this is 2 pi. And your picture doesn't really change much. And your amplitude, this could be 1 and -1, or it could be, 5 and -5. So most of your pictures are going to look the same, at least with the amplitude and the period. It's the shifts that start getting a little bit tricky. So here is our first problem, graphing 2 sine of x. So the 2 is in the position where A is. That means it's going to change our amplitude. Let's go ahead and write out everything for this problem just to practice. So our amplitude is 2. The period is 2 pi divided by whatever number you see in front of the x. This problem does not have a number in front of the x, so our period is just 2 pi. Next, vertical shift. If this had a vertical shift, it would have something like a +3 or a +7 or a -2 at the end of the function. It does not have that, so there is not a vertical shift. If it had a phase shift, there would be something inside with the x, like x minus pi halves or something like that. That would mean right pi halves. But that does not exist for this problem either. So that's our 4 main components. Let's go ahead and graph this. So my period is 2 pi, half of that is pi, and then I've got pi halves and 3 pi halves. My amplitude is 2, so I go up as high as +2 and down as low as, excuse me, -2. Okay, so my sine curve then starts at 0, 0, goes up, comes back down, down, comes back up. That's it. Now, if we finish these last 2 parts, labeling 5 key points, those key points are just so that you understand. This helps more when phase shifts. It's just so you understand what's happening with the curve. So our key points would be 0, 0, pi halves, comma 2, pi, comma 0, 3 pi over 2, comma -2, and then 2 pi, comma 0. You do not have to do that for every problem. That's just to help understand what's happening. And then the domain and range. The domain for all of these is infinite, so we don't need to keep writing that down. And the range is kind of the same concept as the amplitude. though that does change with a vertical shift. So we will write the range down for this one, but our range goes from bracket -2 to 2. That should be enough to get you started. I'm going to do some more complicated graphs next in the next video.